So now we're going to do a little problem here with rate of change. It's talking about Igor's summer job at the frozen yogurt shop. Paid him the following amounts his first 3 days on the job. So this is how much he got paid for the day, and that's how many hours he worked. And what we want to do is we want to figure out, it says, what is Igor's unit rate of change? So rate, dollars to time. So the dollars is 57 and the time is hours, right? Hours. So it'd be 57 divided by 6. They have a calculator. Let me see if I can use their calculator. No. Where am I seeing it? So no, I'm not seeing it. So it's 57. So this is how I do that. I go like this. And what is 57 divided by 6? Ask Google for some help. It says 9.5. And just to confirm it, I would say like this. Let's see. What is 85.5 divided by 9? And that also comes back 9.5. And I can say, what is 66.5 divided by 7? And that also comes back 9.5. So he's obviously getting paid $9.50 or $9.5 per hour. So now the question says, graph the proportional relationship described above. The x-coordinate, on the x-coordinate, the horizontal coordinates representing the hours worked, and the y-coordinate, how much he gets paid. So that's pretty straightforward. If he doesn't work any hours, if it's 0 hours worked, he should get no money, right? So 0 hours, no money. Now, the proportional rate of change, we say if he works 1 hour, he should start getting paid, right? How much should he get paid? So what the key is here for me to understand, these axes tell a story, and I have to read what the problem says. It says the x-coordinate represents the hours worked, so that means over here, when I go over 1, that means 1 hour worked, right? And it says the y-coordinate represents the amount paid, right? So it's really not that hard for me to think, go over 1 and up 9.5, right? If he works 1 hour, he should get $9.5. And obviously, if he doesn't work, he shouldn't get paid. So 0 and 0, that makes a lot of sense, okay? So this is what we call graphing proportional relationships. I'll do maybe one more or so here. Let's see. It's wanting me to go on to something else because it says you're so good, Mr. T. And I'm like, nope, I'm going to not do that. I'm going to go back to where I was. In fact, let me just close that out. I'm going to go in here. Here's your link for this exercise problem. So I'm going to go back into this problem here. And now I'm going to look at this again. It says a proportional relationship is shown in the table below. X to Y. X to Y. So when there's no X's, there's no Y's. I already know I'm going to put 0X and 0Y is right there, right? It says when I go 3 X's, I go up to 1/2 on the Y, 0.5 on the Y. So my line should go over to 3, up 1/2, right? And that would be, if I do that twice, I go out to 6 and up to 1, right? So X goes over to 6, it's up to 1. So there's my line right there. Okay, and I can see that because I know these are the X's, tells me how far right to go. These are the Y's, how far up to go, right? So if I go to the right 6, I go up 1, right? 6, up 1, right? So what is the slope of the line? Well, the slope of the line is simply the triangle, right? The triangle that we would make, right? So if I went up 1, it would take me 6 to get there. So I would write that as 1 over 6. In other words, my triangle, the slope of the line, would go up 1 over 6. It takes me 6 units across to go up 1. So we always write the top, how much it goes up or down on top of the fraction, and how far across on the bottom of the fraction. So I went across 6, that goes on the bottom. I went up 1. And in math class, they often call this the rise over the run. The rise over the run. So how much did it go up on top of how far across did it go? I always think about a kid riding a skateboard or a dirt bike or something, right? If you're riding a skateboard or a dirt bike, let me draw this. Actually, let me see if I can draw this out for you real quick, right? So here I have a little whiteboard. I'm going to try to see. I'm going to zoom in over here. Here's a dude, and he is riding his dirt bike, right? And he's on his light bike, so he's got the handlebars here, right? And his bike is, maybe got some wheel in the front, right? And he's got some, there's a wheel in the back and the motor, right? He's riding his bike. Here he goes. He's going cruising along, right? Now all of a sudden, he's going to hit a jump, right? Well, that's cool. He's going to hit a jump. So the question is, can he hit a 3-foot jump? That's really not that high, right? 3 foot, right? So it's going to be 3 foot. That is no problem. That's 3 foot, right? If he's sitting on his bike, it might be right around here, something like that. So the question is that a crazy jump? And the answer is it depends on this ramp, how many feet before it starts, right? This is the key thing right here, man. If he has this much room to ramp up to it, well then that'll be all right. You can get up to 3 feet and he'll take off in the air and it'll look good, right? But if he only has 6 inches, right? If he only has 6 inches, then basically it's a wall. This is he's going to run smack into this wall and he's not going to go up. He's going to crash. So, I mean, it's not just how tall it is, it's also how long is the base, right? You got to think about both parts, and it's this relationship between how high you go and how much time it takes you to get that high, how far across you drive to get that high, right? If I drove for like a whole mile and I barely went up 3 feet, then that's like I wouldn't even notice I'm going up because it's such a slow slope if it's on a mile, right? But maybe if this is 6 feet and this is 3 feet, that's a pretty good rise. So anyway, we always talk about this thing right here, right? Let me show you. This is the important thing right here, right? This ramp. This is what we call our slope, right? The slope right here. And to describe it, we always have to think about how high it goes and how long it takes to get there. This is called rise. How much does it rise up? This is called the run of the base, right? Like how far across. So when I look at this problem here and it's asking me a question about slope, it's asking me literally what is the rise and what is the run, and I can see that I could run 6 and I would only rise 1, right? If I run, X is always the run, so I'm running 6 and I would only go up 1, so 1 over 6. Okay, it says graph the line that represents it, so there's the line. Okay, just connecting the points that are on there. Okay, maybe I will do, looks like I have time to do maybe one more, and then I'll have you guys work on these. Okay, boom. Graph the line that represents a proportional relationship between y and x, where the unit rate of change with y, with respect to x, is 10 over 7. So this is that same thing, 10 over 7. Okay, so if I were to start here at 0, right, I would go over to 7 and up to 10. Right, so now I have a rise of 10 over 7. That's my slope, my rise of 10 over 7. Right, it's a 10-foot high ramp, but I have 7 feet to go up it. So it's pretty steep. It's pretty steep, but that is it says a change of 1 unit in x. If I just go over 1, I go up 10/7. So that's like almost 1.5, right? It's hard to see that. So now the question is, how would I write an equation? Well, the equation would be something like this. I would say the output or the value of y is, and for is I use equals, right, is going up by 10 over 7 for each x. And I need to put, well, I don't have to, but I'm going to put in here where I would start. So this tells me how the line is changing. It's going up 10 over 7 for each x. And I'm starting it right here at 0. Starting it right here at 0. That's how I'm doing that one. And one more. I know I said that would be the last one, but I'm going to show you one more here. This one tells me what? The y's value is going up 1.4 for each x, or per x. So if I go over 1x, I'd have to go 1.4. I don't know if I can get that. Maybe if I go over 10x, I could go up 14. Or halfway, if I go 5x, I could go up 7. I think that would work, right? Because 10, if I had 10 x's, I should go up 14, right? Because it's 1.4 for each x. So if I had 10 x's, I should go up to 14, but I run out of room. So instead, I'm going to go 5 x's and up 7. That's the same thing, up 7 over 5. So that should work, right? All right, which of the following statements are true? Choose all the answers that apply. So the equation represents a proportional relationship. Yes, it's a proportional relationship, meaning that the y increases for each x. Every time I move x, the y goes up. So, or it could go down, but it always moves the same way. So it is proportional. It says the unit rate of change of y with respect to x is 1.4, and that's true. The unit rate of change of y with respect to x is 1.4, meaning what that means is it means that for each x, the y goes up by 1.4. That's how we write this. 1.4x means for each x, make it bigger by 1.4. All right, so that is correct. The slope of the line is 5 over 7. Well, that's backwards, right? It was actually over 5 up 7. So it should be 7 over 5. So that's not correct. Change of 2 units in x results in a change of 2.8 units in y. That's true, right? Because it's 1.4, and if I did it again, I'd be at 2.8. So 2 units in x should be 2.8 units in y, so that is true. And then it says 3 units in x result in a change of 1.2. No, that is not correct. That'd be 3 units and 1.2. No, that's too little, right? Okay. So that's how those problems are done. You'll be going to this link here to practice them. The last link was bit.ly/ all caps CHS capital M ATH lowercase 8a, and this one is the same but 8b. Those are my shortcut links that I've made for you to get to the Khan Academy site and do some practice problems. And the videos, I'm going to have these in this document here, which you guys can get to. Okay? Thanks a bunch.